So now we will start making our way through the questions in the textbook. And we'll start with the very first exercise in Chapter 1 of Pure. And this is all to do with quadratics and factorising, solving quadratics by factorisation. So in the first set of questions, we just have to solve a bunch of things by factorisation. And the first is x squared plus 3x minus 10 equals 0. And remember, we want to find, in our brackets here, we have an x and an x, two numbers that will multiply to negative 10 and add to 3. And that will be 5 and minus 2. Because 5 times minus 2 is 10, 5 plus minus 2 is equal to 5 minus 2, which is 3. And that still equals 0. And obviously we could have expanded this to check, but I'm fairly sure it's correct. So now we have two things multiplied together, they get 0. That means at least one of them has to be 0. So x plus 5 could equal 0, or x minus 2 equals 0. So the answer will be x equals minus 5 or x equals 2. Then next we have x squared minus 7x plus 12 equals 0. And again, we want two numbers that will multiply to 12 and add to minus 7. So we'll have x minus 3 and x minus 4. And that will mean x minus 3 equals 0 or x minus 4 equals 0. That means x equals 3 or x equals 4. In C, x squared minus 6x minus 16 equals 0. And that will be a minus 8 and a positive 2. Remember that two positive numbers multiply to get a positive number, two negative numbers multiply to get a negative number, but a positive and a negative number multiply to get a negative number. Then x equals 8 and x equals minus 2. Now here is where it gets slightly harder when the lead coefficient, the coefficient of x squared, is not 1. So what I would do here is I would say that AC, which is 5 times 12, is equal to 60, because we're doing the constant multiplied by the lead coefficient. And now we want two numbers that multiply to 60 and add to 19. And that will be 15 and 4. And now we factorise in two halves. If we remove 5x from 5x squared plus 15x, we get an x and a 3. And then we add this to taking out the 4 of this side, the highest common factor of this side. We take out the 4 because it's the highest common factor. And now we have x plus 3 repeated. And that's like saying, okay, we're having 5 lots of x plus 3, and then we're adding 4 lots of x plus 3. So that can further be factored, because x plus 3 is a common factor there. And now we're looking at something a bit more familiar. So 5x plus 4 can equal 0, which means 5x is minus 4, and so x is minus 4 over 5, or x plus 3 equals 0, and x equals minus 3. Now, for E, this is by no means any different to the previous one. It just requires a bit of rearrangement. So here, we remember to solve a quadratic equation, it must equal 0. So we will add 7x to this side, and then subtract 20 to give us 0. Now AC will equal minus 120. And so now we have to think of two numbers that will multiply to minus 120 and add to 7. and off the top of my head, that will be 15x and minus 8x. And then we do the same thing of removing a common factor in the two halves. Remember here, we've got a minus and a positive, which will get us to that negative. And this equals 0, and we do the same thing of extracting that common factor of 2x plus 5. This means 3x minus 4 equals 0, 3x equals 4, x equals 4/3, or 2x plus 5 equals 0, 2x equals minus 5, x equals minus 5 over 2. As you can see, really not that much difference there. Just do some rearrangement. Then the last one for question 1 is x bracket 10x minus 13 equals 3. Now, maybe you might have instantly gone, oh, x equals 3, 10x minus 13 equals 3, but that's just wrong. That sort of thing only works with 0 because of the fact that anything times 0 is equal to 0. So first we must first expand. 10x squared minus 13x equals 3. Now we must make it equal 0. And then we can factorise by doing AC equals minus 30. And hopefully you can see that that's going to be minus 15x and 2x. And we'll remove a common factor. And now here, what we have in here is just exactly this thing here. And that means you need to think about how we can factorise this next part. You can think of it as this being one lot of it. So this is why we do 5x plus 1. 2x minus 3 equals 0. And you know the drill. Good. So that's a bit of factorising, and now things will start to get a slightly more difficult, just a bit more steps of algebra needed, but nothing that you can't handle. So for A we have this. Right, so what do we do here? Now, back in primary school, you would have been learning how to, make equivalent fractions and add fractions and all that and subtract fractions. And the reason why you do that, and because sometimes maybe it feels like that's a bit pointless because you can just use a calculator. But an example like this question is exactly why we learn about how to add and subtract and multiply and divide fractions. Because we need to know how to do that without a calculator, because sometimes it won't be numbers that we're working with. And that's exactly what's happening here. So if you remember how we subtract fractions, we need a common denominator. And to make a common denominator, we would multiply by, say if we're doing 1/3 plus 2/5. What we would do here is we want to make this 1/3 multiplied by 5 over 5, because that's 1, but when we do that you get 5 and 15. It's equivalent fraction, but it's in a different form with a different denominator. And then for 2 over 5 we do 2 over 5 times 3 over 3. It's the same thing. This is just 1. It just changes the denominator and numerator, but keeps it equivalent. And then you could add these. and that combines them into one fraction, and that's exactly what we want to do here. Over here, this denominator is 1, so we don't really need to worry about it, but what we would do is x multiplied by x minus 5 over x minus 5 minus 6 over x minus 5, which is equal to 0. And so now we get x minus 5 minus 6 all over x minus 5, which is equal to 0. And if we expand this, x squared minus 5x minus 6 over x minus 5 equals 0. And here is another fact. This 0 is also equal to 0 divided by x minus 5, because 0 divided by anything is still 0. So this means that the denominators are the same, which means we can just ignore them, leaving us with x squared minus 5x minus 6 equals 0. And now we factor this. If you noticed, I almost wrote x minus 2, x minus 3 to get negative 5. But and remember 2 times 3 is 6, but here we don't have this right arrangement of signs for it to be equal to negative 6. So that's wrong. Luckily, I caught myself there. So that means x will equal, well, if you want this extra step of working, and you get that. Now in B, we have a similar thing, but this time they're not as nice, and nothing's got really a denominator of 1 that we really care about. So now what we have to do here is, like we did with that example of, say, 1/3 plus 1/5, we had to go multiplying both of them by the other denominator, like that. And that's exactly what we have to do here. 2x plus 2 over x plus 2 here. And then over here we need to do x's. Multiply x over x. And again, we have to do the same with this side here. But with a constant term, you'd have to multiply it by both denominators like that. Now, denominators are the same, so we can ignore them. Now we must expand. If we rearrange to make it 0, we will get this. And then if we factorise, we will get this. So x minus 4 equals 0, or x plus 1 equals 0. X equals 4, or x equals minus 1. And we'll just keep on punching with 5x plus 1 over 4 minus 2x minus 1 over 2 equals x squared. This is honestly easier, because now we just need to double this and then multiply that by 4. So we can rewrite this as this. I've just doubled 2x minus 1 to get 4x minus 2. And I've turned this into 4x squared over 4. Because those would cancel out to get x squared, and these would cancel out to just get that if you factorised it again. And now we see denominators are the same. And here's where we need to be careful. Just checking if we made that. Okay, no, good. We are minusing this, and you have to imagine some brackets here. So if we are doing this, this is the same as subtracting 4x but then adding that 2. And so we get something like this. And now we will do our AC equals minus 12, and then find numbers that multiply to negative 12 and add to minus 1. So that will be this. I think you're starting to get the idea now, but we'll just keep on going through these questions. Remember, this is an important note about the signs here. We're doing a bracket, so then this is almost like you imagine you've got a negative 1 in front of there, and then you have to expand the bracket. Negative 1 times 4x is minus 4x, but then negative 1 times negative 2 is positive 2. Which means you have to add it. Now the next one is kind of a similar thing. And so we must do the same thing of multiplying by the other denominator. No point expanding the denominator because we hope to just remove it later on. And good, we've got the same denominators now. We can just work on expanding the numerators. And now we'll rearrange things to one side. X squared. I'm just crossing off all the like terms as we go so I don't miss stuff out. It looks like these things are equivalent, so they will eliminate, and leaving us with only minus 4 equal to 0. Right. Now, here are two ways you could go about this from now on. There is the factorisation way, or just some rearrangement. Here is the way I prefer to do it, having done a lot of this. I would love to see that this is a difference of 2 squares. Remember that a squared minus b squared equals a plus b, bracket a minus b. And then I'd say x equals minus 2 or x equals positive 2. And of course you could add that extra step of working like this. The other way you could do it is just say, x squared will now equal 4, so x will equal plus or minus root of 4. X equals 2 or x equals minus 2. Either way is probably acceptable. Now we do 3 over x plus 1 plus 1 over x plus 1 equals 2. Now notice how they've already got this common factor, which means you only need to multiply the first one by another x to make it the denominators common. And now the denominators are the same, so we ignore them. We rearrange. AC equals -2. In this case, you probably wouldn't even need to do this, but I clearly, as you can tell, I insist. Notice how I factored out this -1. So this means x minus 1 equals 0, or 2x plus 1 equals 0. So x equals 1, or 2x equals -1, so x equals -half. If 3 over x plus 2 plus 1 over x minus 1 equals 1 over x plus 1, x plus 2. So this will mean, okay, 3x minus 1 over x plus 2, x minus 1, plus x plus 2 over x plus 2, x minus 1 will equal 1 over x plus 1, x plus 2. That's starting to look quite good, but notice a subtle difference in this. It's got that positive sign. So what we need to do actually is also multiply it by x plus 1 as well. And I'll add in this x minus 1 here. Now, this is starting to look like a cubic thing, but remember, because the denominators are the same, we can ignore them. So we're left with this. And now we can expand this. Now this is the reversive difference of two squares, so it's just like that. And then we have x squared plus 3x plus 2 plus x minus 1. And so this is 3x squared minus 3 plus x squared plus 3x plus 2 equals x minus 1. That's 4x squared plus 2x. And I think that happens to simply be equal to 0. And if we factor this out, so 2x equals 0, x equals 0, or 2x plus 1 equals 0, 2x equals minus 1, x equals minus 1/2. That's our answer. And next we need to, well, I'll just, before I move on to the next part, just remember that getting common denominators is very important. 3a, we have 3x squared plus x minus 10 over x squared minus 7x plus 6 equals 0. And if this equals 0, it doesn't matter what x squared minus 7x plus 6 equals, because anything 0 divided by anything is 0. If we were to multiply both sides by x squared minus 7x plus 6, you get 3x squared plus x minus 10 equals 0. And that's exactly what we will solve. AC equals minus 30. And we'll be using a combination of 6 and 5. And we will just do this factorising. I mean, it's very repetitive, but you've got to just keep doing it. So 3x minus 5 equals 0, 3x equals 5, x equals 5 over 3, or x plus 2 equals 0, x equals minus 2. Now b, it's the same thing again. And so this is x squared plus x minus 6 equals 0, x plus 3, x minus 2 equals 0, x equals minus 3, or x equals 2. I'm starting to skip a bit of working because I think you kind of get the idea, and just want to keep this moving fast. Again, doesn't matter what this denominator is. Remember, difference of two squares here. It always comes up. Right. Now, this one... Again, doesn't matter what the denominator is, because that top thing is just going to equal 0. And an important thing about here is this actually is a bit of a special case with factorisation. This gets you now, you may immediately think this. However, this is not the right answer. And you need to think about, actually, when I said the denominator doesn't matter, in this case it actually kind of does. And you probably really should, you should check in all of these ones that when you substitute it in the denominator, your answers in the denominator, they do not equal 0. I have been rather reckless and not checked, but that's because these quite obviously would not end up as 0, and I can tell that. But in this case I can see, right, if we do minus 2 this will equal 0. This is positive 4, this is minus 14, and this is 10. So that'll equal 0. And in maths, you cannot divide by 0. So this is why we reject this bit and accept only x equals 4. And I'll just go, those ones are fine, because they're variables, so that was a different type of question. These ones, I can tell that, okay, 5 over 3, when you start putting 5 over 3 in there, you're not going to get to 0 because you've got squares and then just multiplying it by 7. So that wouldn't work, I know. And for minus 2, I can tell, well, that's going to be 4. And then this, because minus 7 times minus 2 is going to be positive, we're adding something and then we're adding something again. So I can tell that won't be 0. But obviously in working you should write it out. And obviously I can tell right here, x plus squared plus 5, neither of these are going to get me to 0. And it's the same thing with 7x plus 10. But for this one I can tell, oh yeah, that might be a bit dangerous. Because you're going up, you got a positive, then you got a negative, then you got a positive again. So that's a bit of danger. But you should fully write out working for that. And you just need to evaluate this, say 4x squared plus 7 times 4 plus 10 does not equal 0 or whatever, just to show some working there, but you really should. I probably should have said that earlier, but we'll keep on going. 6x squared plus x minus 6 over x squared plus 7x plus 4 equals 0. 6x squared plus x minus 2 equals 0. AC equals minus 12. 6x squared plus 4x minus 3x minus 2 equals 0. And we'll factor this out. 2x bracket 3x plus 2 minus 3x plus 2. So now we get 2x minus 1 bracket 3x plus 2 equals 0. So 2x minus 1 equals 0, 2x equals 1, x equals 1 half, 3x plus 2 equals 0, 3x equals minus 2, x equals minus 2 over 3. Now let's check. Half squared plus 7 times 1 half plus 4, it doesn't equal 0. And then minus 2 over 3 squared plus 7 times 2 over 3 plus 4 also does not equal 0. Well, good. Now we'll move on to F. And we'll solve the numerator. AC equals minus 10. That was a very free factorisation there, I tell you. Get 2x minus 1. Multiplied by x plus 5, and that's equal to 0, so 2x minus 1 equals 0, 2x equals 1, x equals 1 half, x equals minus 5. And now we would check for that denominator. In order for, and actually we honestly don't need to check the denominator because we know that a fourth power will always be positive, and you're adding 1, so it cannot be 0. So I'd say I would say that this always greater than 0. Maybe that could be a justification. And next we will do another form of a quadratic. Something like this. Now the problem with this is we've got both different bases and different powers. Except that perhaps we don't, because 1 to the power of anything is 1. So we could write this as this. And then we would say, okay, the powers are the same, so we treat the bases as being equal. But in what world does 8 equal 1? So that doesn't... 8 equals 1, false solution. So instead, we need to get a bit more creative. And think about the powers of 8. Let's try to make the bases equal instead. 8 to the power of some k to equal 1. And remember that anything to the power of 0 is 1, with the exception of 0, because 0 is weird. And now, because the bases are the same, we can say that the powers are equal. And now this just factorizes. And then for the next one, it's a very similar thing. And this is just for so 2x minus 11x plus 15 equals 0. AC equals 30. So now I have 2x squared minus 5x minus 6x plus 15 equals 0. And so we get this, and then we factor this out. We get what am I doing? We need squares. So we get x, 2x minus 5 minus 3, 2x minus 5 equals 0. So x minus 3 multiplied by 2x minus 5 equals 0. X equals 3 and x equals 5 over 2. C, 2x squared minus 4x plus 6 equals 8. Now this is 2 to the power of 3. So that means 4x plus 6 equals 3. 0, and now we just do minus 3. X minus 1. So x equals 3 or x equals 1. Now for the next one, we do 2x squared plus 9x plus 2 equals 1/9. And that is equal to 1 over 3 squared, which is equal to 3 to the power of minus 2. So 2x squared plus 9x plus 2 equals minus 2. So that means 2x squared plus 9x plus 4 equals 0. AC equals 8. 2x squared plus 8x plus x plus 4 equals 0. 2x, x plus 4 plus x plus 4 equals 0. That means 2x plus 1 multiplied by x plus 4 equals 0. 2x equals negative 1, x equals minus 1/2, x equals minus 4. And then we have x squared plus 2x minus 14 to the power of 5 equals 1. And that's and we can say that in this case that this is 1 to the power of 5. And then we can say, because the powers are the same, this expression quadratic is equal to 1. And we can do this. And we can factor this very easily. So that means x is equal to minus 5 or x equal to 3. Now in this next question, it's slightly harder. Because now this can be equal to 1 to the power of 8. But what if it's also equal to negative 1 to the power of 8? Because all negatives to even powers are positive as well. So this is why we have to do split it into cases. Either x squared minus 7x plus 11 will equal 1, or x squared minus 7x plus 11 will equal minus 1. And then we'll factor this very easily to get x equals 5 or x equals 2. But then on this side, it'll factor easily. So we get this. So x is also equal to 4 and x is also equal to 3. So then we'll just keep going on, and we're given a diagram of a triangle. And we're saying this is 29, this is 2x, and this is 2x plus 1. And we need to first show that 2x squared plus x minus 210 is equal to 0. And I think what we should be doing is be using Pythagoras and then rearrange it to get that equation. So we should be saying that 2x squared plus 2x plus 1 squared is equal to 29 squared. That's equal to 841. This is 4x squared, and this is 4x squared plus 4x plus 1. So that gives us 8x squared plus 4x plus 1 is equal to 841. So that's 8x squared plus 4x minus 840 being equal to 0. Now if we just divide this by the smallest number there, which is 4, we'll get 2x squared plus x minus 210, which is equal to 0. And so that proves that expression, that equation, QED. B, find the lengths of the sides of the triangle. Well, we can just solve this equation now. Plus x minus 210 is equal to 0. AC is equal to minus 420. And because obviously it may be faster to do the quadratic formula, but in this case I still think it's okay to factorise, because look at this, it says it's just plus x. So that means whatever we're dealing with is the two numbers that we want are only one apart. And I think this 400 is 20 squared, so it's going to look quite close to 20. And I can instantly say that if 400 is 20 times 20, then 420 will be 20 times 21. So I'll just chuck that in. And remember, we got a minus and we want positive x, so we have to do a positive 21, but then a negative 20. And then we factor this out. Then we get this. We will reject negative because we're dealing with side lengths which are positive. So we can say that x has to be equal to 10. And that means 2x will equal 10 times 2, which is 20, and then 2x plus 1 is equal to 2 times 10 plus 1, which is 21. So the side lengths are 20, and we should say in centimetres, 20 cm, 21 cm, 29 cm. Now for 6, it's another geometry-related question. And I'll just draw up the diagram for you now. This is by no means to scale. And you just have to imagine these right angles. I don't know if they're perfect. X plus 3, x minus 1, and x. And it says the area is 35.75 cm squared. And we need to figure out the value of x. I might take this down to another page, actually. So we know that the area will be equal to, we call this A, we call this B, and call this H. A plus B over 2 times H, because you average out those side lengths and multiply it by the height. So if we substitute our things in, we get sort of this stuff. That's 2x plus 2 over 2 times x. And if we were to factor this out, that's 2x plus 1 over 2. This will cancel. So we get x squared plus x, because that's x times x plus 1. And that's equal to 35.75. And we could then just multiply this out to get whole numbers. And then AC is equal to minus 572. And then we would have to try and figure out a way to factorise. And then we'll end up with 26 and 22. And now we have to try and factorise this. And again, we ignore the negative because we're dealing with side lengths, so and now on to the final question of the exercise. We need to solve the equation x squared minus 11x plus 29 all raised to the power of 6x squared plus x minus 2 equals 1. Right. So here are a few cases. This could very well be x squared minus 11x plus 29 to the power of x squared plus x minus 2 being equal to 1 to the power of 6x squared plus x minus 2. Or it could be x squared minus 11x plus 29 to the power of 6x squared plus x minus 2 being equal to x squared minus 11x plus 29 being to the power of 0. Which means we must solve two equations, one being this and one being this. And these are very easy to solve. So we get x equals 7, x equals 4, and on the side we get, AC equals minus 12, 6x squared plus 4x minus 3x minus 2 equals 0. And this means that 2x times by 3x plus 2 minus 3x plus 2 is equal to 0. 2x minus 1 multiplied by 3x plus 2 equals 0. 2x equals 1, so x equals 1 half, x equals minus 2 over 3. And so that means we've got 4 answers. So all in all, that's exercise 1A of Pure, which is quadratics, and it's all about factorisation, which is why I've tried to only use factorisation. And at the start, it was just very simple stuff. We had to factorise stuff where the lead coefficient was just 1. Remember, 2 numbers that multiply to this and add to that. And then we had stuff where the lead coefficient was not 1, where we multiplied this to get something that you needed 2 numbers to multiply to and 2 numbers to add to this one here. Then when you got into stuff where you needed a bit of rearranging or a bit of expanding. And it was over here we started getting into fractions, getting common denominators and stuff. And that was all good. And then in this example, in the third lot of third question type, you needed to be careful that you didn't get solutions that had you dividing by 0. But honestly, the same stuff as getting common denominators was the important part, I think. And then you started getting stuff with exponents. And remember that x to the power of 0 is equal to 1. I should know that x shouldn't equal 0. 1 to the power of x is equal to 1. Anything to the power of 1 to the power of anything is 1. So those two things are probably the key things there. And here's just a bit of application, a bit of application of Pythagoras there. And more mensuration and stuff. And a big exponent one here. But that's all for that video then. I'll see you in the next one for exercise 1B.